Hello, you're welcome. So today we're going to find the domain and range of functions. Okay, so we're going to start with the following rational function. When we talk about the domain, we're talking about the set of numbers for which the function is defined, right? And when we talk about the range, we're talking about the possible outputs of a function. Okay, so now this is a rational function. If you talk about the domain, we're looking at the denominator because the denominator is not going to be equal to 0. If that happens, the function will be undefined. It leads to division by 0. So what we're going to do here is we're going to not let x minus 3 equal 0. So this denominator is not going to be equal to 0. So when you add 3 to both sides, we get that x is not equal to 3. And that's true, right? If x is equal to 1, the function is defined. If x is equal to 2, the function is defined. If x is equal to 0, this function is defined. Then when you plug in x equals 3, it leads to 8 divided by 0, which is division by 0. And that's undefined in mathematics, right? Okay, so in interval notation, this domain is going to be as follows. We're going to have all the way from negative infinity and here 3. We're going to put a bracket and not a brace because 3 is excluded. Then union, we're going to put a bracket again. We're going to have 3, then comma, positive infinity. You get the idea? Now we're talking about a rational function and we wish to find the range. To find the range, we're going to find the inverse of this function, and the domain of the inverse of the function will give us the range of this original function. You get the idea? So this is how we're going to do it. I know you guys know how to find the inverse of a particular function, so we're going to let this function y equals x plus 5 divided by x minus 3. So from here, we're going to solve for x in terms of y. So cross multiply, we get y into bracket x minus 3. This is going to be equal to x plus 5. We need to open this bracket. So we get here yx minus 3y is equal to x plus 5. Now collecting like terms, we get yx minus x. This is going to be equal to 5 plus 3y. Remember, we're solving for x in terms of y. So at the left hand side, we can factor out x. It is common, right? So we get y minus 1, that this will be equal to 5 plus 3y. Now divide both sides by y minus 1 and we get the x value in terms of y, which is going to be 5 plus 3y divided by y minus 1. Okay, remember the original function is x plus 5 over x minus 3. So we have this original function as x plus 5 divided by x minus 3. Now, in this x value, we're going to replace y with x, and that is going to give us the inverse of this function, which is going to be 5 plus, it is not going to be 3y, but 3x. And then divided by y minus 1, it will be x minus 1. So this is the inverse of this function. Okay, if you don't understand what this inverse of a function mean, what is the difference? Now, look at what is going on here. If you make an input into this original function, the output it will give you, if that output becomes the input of the inverse function, it will give you back the input of the original function. So this is what I mean. Here, if you make the output of 1, it is going to give you, that is if you let x equals 1, so it's going to give you f of 1 is going to be 1 plus 5 divided by 1 minus 3. This will give you 6 divided by 1 minus 3 is negative 2, giving us negative 3. You get the idea? Now this output here is going to be the input in the inverse of the function, and the output it will give you now is going to be the input of the original function. So here f inverse of negative 3 is going to be equal to 5 Now, plus 3 times negative 3 is giving us negative 9. You get the idea? So here, divided by, this is going to be negative 3 minus 1. Here we get negative 4 divided by negative 4, giving us 1. Take a look at this output. This output is the input of the original function. So you see what is going on? So that is what we mean when we talk about the function itself and the inverse of that function. Okay. So now, just like I told you, the range is also known as the codomain, right? So here, remember we have already found the domain as negative infinity to 3 in union 3 to positive infinity, and we need the range. So the domain of the inverse of this function is going to give us the range of the original function. So here, we know to find the domain of this inverse function, the denominator is not going to be equal to 0. And from here, we see that x is not equal to 1. Therefore, the domain here of this inverse of this function is going to be negative infinity all the way to 1, and then union 1 to positive infinity. And therefore, the range of the original function is going to be negative infinity all the way to 1, then union 1 all the way to positive infinity. So this is how you can find the domain and the range of a given rational function. I think this makes sense, right? Okay. So this is telling us, for the range, it is telling us that this function is going to have several outputs or infinite number of outputs, but except one, right? So we're going to obtain any output 1. That's why 1 is excluded. So let's check about the second rational function we have on the list. So say we have f of x is equal to wait, I'm coming guys. So the next one here on our list, so we have that is 5x minus 1 divided by x plus 6. Okay, and we're going to find the domain and also the range. Okay, now we know we're talking about the domain. Sorry for wasting you guys' time. So we're talking about the domain. We know this is a rational function, so the denominator is not going to be equal to 0. So here we're going to say x plus 6 must not be equal to 0. Okay, and from here we see that x is not, if you subtract 6 from both sides, you see x is not going to be equal to negative 6. So the domain is all real numbers except negative 6, which in interval notation, the domain is going to be from negative infinity all the way to negative 6, union from negative 6 all the way to positive infinity. Just like we did in the previous one. So we're going to find the range by first finding the inverse of this function. So we're going to let y equals 5x minus 1 divided by x plus 6. Now we're going to cross multiply and solve for x in terms of y. So we get y into brackets x plus 6. This is going to be equal to 5x minus 1. So from here we get yx plus 6. That this is equal to, plus 6y. Sorry for that. That this is going to be equal to 5x minus 1. Collecting like terms, we get yx minus 5y is going to be equal to negative 1 minus 6y. Now you can factor out x from the left hand side of this equation. So we get x into bracket y minus 5. This is going to be equal to negative 1 minus 6y. Divided by y minus 5, we get x is equal to, factor out this negative sign, we get 1 plus 6y divided by y minus 5. With the negative sign, we change the sign at the denominator, we see that we get 1 plus 6y divided by, it will become 5 minus y. So this is the inverse of this function. So we say the inverse of the function is going to be equal to, replace y with x, we get 1 plus 6x divided by 5 minus x. Now we need the domain of this function here, this inverse function, and that domain is going to give us the range of the original function. So for that, 5 minus x, which is the denominator, is not going to be equal to 0. So from here we see x must not be equal to 5. This makes sense, right? Therefore the domain, the range of the original function is going to be negative infinity all the way to 5, comma, then union 5 all the way to positive infinity. And that's it. Okay, so let's check the next one on our list. Okay, so the next one here we have an irrational function, right? So we have f of x is equal to the square root of x plus 2. Okay, so the square root of x plus 2, and we're going to find the domain and also the range. That's interesting, right? So this is what we're going to do when you have a square root function or irrational function. So anyhow, just make sure, okay, let's call it a radical function. Okay, that makes sense, right? But not in this form. If it is in the form of a fraction, then it is going to be a different case. But once we have a square root function like this, and we wish to find the domain, we know that the square root is not defined for negative numbers, right? So this actually tells us that the x plus 2 under this radical must be greater than or equal to 0. So far we know that the square root of 0 is defined, right? So x plus 2 can be equal to 0 or greater than 0. So from here, subtract 2 from both sides, we see that x must be greater than or equal to a negative 2. And for the domain, we say the domain is going from negative 2 to positive infinity. But remember that negative 2 is included. So this time around, we're going to have a brace like this, which shows that negative 2 is included, then all the way to positive infinity. So this is the range. This is the domain. Sorry for that. Now, how do we find the range? So the range, now we're going to make the following input starting from the negative 2, right? So if you plug in negative 2 here, so remember when we're talking about the range, we're talking about the f of x values, right? So starting from the lowest. So here, if you make the input of negative 2, then we're going to have the following. That is square root of negative 2 plus 2, which is equal to square root of 0, which is given us 0, right? So, and x is greater than or equal to negative 2. So after negative 2, the next in the domain is negative 1, right? Does that make sense? Because negative 1 is greater than negative 2. So if you make this input of negative 1, you will see something is really changing. So this is going to be the negative 1 plus 2, giving us square root of 1, giving us 1. Or we can see that this is going from 0 to 1. Okay, if you make, let's say 2, because 2 is in the domain, we get square root of 2 plus 2, giving us square root of 4, giving us 2. So you can say we keep getting positive values. So this is telling us that the range is the 0 included. Yes. So the 0 is included, right? So the range is going from 0 to infinity. So we have 0, right? Because 0 is included, then all the way to positive infinity. So this is the range of this function. You get the idea? Okay, so let's move to the next function. Okay, so this is the next one. This is a polynomial function, right? And we wish to find the domain and also the range. But there's one thing you need to know about polynomials. Their range is all real numbers, right? Because these functions are always defined for all real numbers, right? So we can easily detect the range as negative infinity to positive infinity without wasting our time. So this is for all polynomial functions, okay? Okay, now we have this function x squared minus 3 and we're going to find the range. So how do we find the range? First of all, let us plot the graph of this function, just a rough sketch, okay? So we have the y-axis, oh sorry for that, this is just a rough sketch, and the x-axis. So remember, if x is equal to 0, we get negative 3, right? So we get negative 3. I think this is going to have a minimum point at negative 3, okay? So this graph is shifting 3 times downwards, okay? So here it is, remember this guy here is positive, so it is going to open upward. So here, let's say here we have negative 1, here we have negative 2, and here we have negative 3. Oh, I mean, actually, when I said about the minimum point, that is, it is at negative 3, right? Not positive 3. So here, the graph is going to look like this. Okay, so exactly like this. And we're talking about range, and we can see the list here along the y-axis here is negative 3, right? And this guy keeps moving upward like this, right? So we can say that the range of this function is negative 3, comma, positive infinity, because the negative 3 is included. So now there's something you need to observe. Okay, let's do some practical inputs here. Now, if you let x equals, we know this function here, x squared is even, right? For all negative numbers, it is giving us positive outcome or positive output. So if you let x equals negative 1, we get negative 2. You get the idea? If x equal to negative 3, we get 0. If x equal to 0, we get negative 3. So we can see that, honestly, this guy keeps moving upward along the y-axis. So that is for polynomial function like this. So here is the domain and here is the range. So let's see the next one on our list. So the next one we have here is, so the next one here we have also a polynomial, but this is a quadratic function. So we have f of x is equal to okay, so we have f of x is equal to, that is x squared minus 4x plus 5. So x squared minus 4x plus 5. So this is a polynomial. Just like I told you guys, the domain is still for all real numbers. So it's going to be from negative infinity to positive infinity. Then we're going to find the range. So we need the vertex of this function. So we need the vertex. So I will show you guys two different ways you can find this vertex. So the first one, we can use the formula x is equal to negative b divided by 2a, right? So here we know that our a here is going to be coefficient of x squared is 1. So our b here is going to be equal to negative 4 and our c is equal to positive 5. So here x is going to be negative 4 is going to be negative minus 4. Then divided by 2 times a will be 2 times 1. So this is giving us 4 divided by 2, leaving us with, oh, that would be 2. Okay, so that is going to be 2. Then we're going to plug it into the function to get the corresponding value for y. So we get f of 2 is going to be equal to 2 squared minus 4 times 2 plus 5. So this is giving us 4 minus 8 plus 5. And this is giving us 1. So the vertex is going to be 2 comma 1. Okay, so another way we can find the vertex here is through completing the square, right? So here we're going to have, we have x squared minus 4x, I think so. So minus 4x and then plus 5. So here this is same as x squared minus 4x plus 4 and then plus 1. Since we know that 4 plus 1 is equal to 5, so here this is a perfect square. And that is x minus 2 whole squared and then plus 1. So from here we can find the vertex, right, as 2 and then comma 1. Then we need to plot the graph of this function. So this is, so here, remember, according to the vertex, put it down here, 2 comma 1, right? So 2 comma 1. Is that 2 comma 1? Yeah. So 2 comma 1. So along this x axis, so here is 1 and somewhere here is 2. So let's say our 1 is somewhere here. So the graph will look like this. Remember, the equation, the expression or quadratic expression is x squared minus 4x plus 5. So this guy is positive, so it's going to look upward. So this is going to go like this and then like this, okay? So we can see this is starting from this -1 here, and you can see that this guy is always positive this side, so it is moving upward like this, right? So that tells us that the range 1 is included and then all the way to positive infinity. Okay, so that's for some functions about range and domain. Okay, so if you really enjoyed this video, please don't forget to support this channel by giving us a subscription. Okay, you can also like, comment and share, and bye bye.